Hello, my name is Jason Edstrom. I am a lead quality engineer for Cognizant Softvision. Welcome to my presentation talking about how to develop a multi-platform framework and creating the skills and the flexibility and also the efficiency that we need for that design pattern. If you have any questions, please put them in the chat and we'll try to address them at the end of the presentation. So without further ado, let's jump into Lord of the POMs multi-platform framework design. So to give you just an initial idea of who I am, I have been in IT for about 15 years, everything from IT technician to a developer and engineer, as well as an architect. I've been in quality for about 7 years. I've had opportunities to lead groups of individuals, whether it be side open source projects or work projects. I'm a huge mobile enthusiast. I've done hardware repair, I've been a mobile developer and done mobile automation, which you will see a decent amount coming up in this presentation. Another little fact about me is that I'm a chronic early adopter. And what I mean by that is more times than not, I am usually running something that is not fully in production yet, whether it be an operating system or an application or whatever the case may be. So I love seeing the bleeding edge consistently, and I kind of subject myself to that on a regular basis. And I'm also a notorious edge case, and what that means is that I like to stretch my understanding to the limits of what I'm working on and then try to break those limits as well. So I tend to do a lot of thinking, refactoring, refining of my approaches because I always want to do it a little bit better. So that's a little bit about me. And we're going to kind of dive into talking about what mobile automation is and frameworks are. So one of the things to remember as you're going throughout this presentation is that I'm going to talk about it from the context of mobile automation and automating mobile apps and mobile devices. But these concepts can be applied in a number of different other areas, like standard web automation. You can also think about it from a standpoint of thick client as well, if that's what you're working on. So you get a lot of opportunities to apply these concepts in more than one area, not just necessarily mobile, but that's where a lot of my initial experience of developing this pattern come into play. So let's talk about what type of mobile applications are out there and what types there are. So you have the native approach that we are consistently used to. You have iOS apps that are made out of Objective-C and now Swift. And then you also have Android apps that are made out of Kotlin and Java. Kotlin is a derivative of Java, so it makes sense that they work together. One of the next ones is something that I call a translated app, or where the code is not necessarily native, but the elements are translated in such a way where they are more so native UI elements along the way. So Flutter does that, Xamarin does that, and React Native does that as well. A lot of time, like with Xamarin, they use like a C# runtime to take care of some of that. The next one is a hybrid app, and this is where people utilize the responsive design of a web page and then wrap that inside of an app package. So you're still downloading an app and still installing an app off of an app store, but it is calling out to web pages and kind of formatting in a way that is consistent with mobile platforms. And then you have just strict web, where you go to a web app and then interact with it as well, and it primarily uses mobile elements to give you that workflow, that UX flow. So those are kind of the four major areas that come into from mobile applications. We'll see more develop in the future because mobile is very quick to change. But for right now, this is kind of what the landscape is in terms of mobile apps. So one of the things that kind of came to mind is was that I was dealing with frameworks and having issues developing them differently and efficiently, and I kept on coming into these roadblocks. So I decided to build a set of guiding principles that would be basic expectations for me in order to feel that it was a good mobile framework. One of the first steps is that that shared single test class. It is nice to only have to deal with one test and not have to necessarily keep the traceability or the coordination between the different platforms. Say if you were working on a tablet, two phones of different operating systems on two tablets. It would potentially be a scenario where you'd need to create 2 to 4 operating or test classes for that. And one of the guiding principles is that I want to slim that down as much as possible. The next part is cross-platform, that I am able to function across multiple platforms without having kind of to reinvent the wheel over and over again. So that was kind of a big piece, is that it needed to function as is without major rewrite. One of the next big pieces, this comes up a decent amount in mobile. It happened more so in the past, but it still has the ability to happen nowadays, because Android and iOS have different design patterns in terms of UX. So application divergence. What I mean by application divergence is that the different platform dictates that the functional workflow changes. You see that a lot of times in login portals, where one device will show it one way, one device will show it a different way. So that is a good example of needing flexibility, is that the application divergence scenario, you need to be able to accommodate that. Performance, we want it to be very performant. We don't want to have to do a whole bunch of extra calls and manipulations in order for the automation to succeed. So performance is kind of a big detail. When you want an element, a page element or a UI element, you're getting that one element rather than having to do multiple interactions to accomplish the same task. And then the last piece is we want to start using shared code consistently across the platforms. So that way we are able to write it once, not have to duplicate. We can keep our framework simple and approachable for new automation engineers. And then we have some stretch goals. It was nice to kind of walk through some stretch goals and get those in place, because these are kind of like, these are not deal breakers necessarily, like the previous ones. The previous ones were kind of bigger necessities, but there we go. But with these, they're definitely nice to have. So readability is one piece, whether it be the diagramming, the test, the page object model, we want to have that readability there. And so just even for making it easier for us to find the bugs, it also allows for easy ramp up and easy teaching as well for new engineers along the way. Design consistency enforcement, being able to be consistent across your entire framework by using your conventional standards is a really nice component that it kind of just feeds into itself. And that kind of comes along with the use object-oriented principles. We have these founding principles for a lot of the languages. And by using those and elevating those skills, we are able to build a better framework. Another big piece is traceability. We want to know where the errors are coming from. We want to make it efficient for debugs, for debugging errors and tests, but and so therefore we don't want like magic to happen underneath the hood and therefore get a really poor logging message when we have to do troubleshooting. And then as one extra piece for this we don't just want to cover application divergence, but we want to cover device divergence as well. And the important part for device divergence, it comes from tablets and phones. So tablets typically use master lists and detail views, which is inherently different than the phone's approach of shifting the scene from one direction to the other. So this was the journey that I ended up going through over the course of my years getting into mobile automation. It was a pretty important learning piece. So we're going to walk through the isolated framework, kind of talk about what that is. We're going to take a look at what conditional page models are and kind of how that feeds into the story. Then we're going to talk about page factoring, kind of what it is trying to do and where it succeeds and fails in terms of automation. And then the last one, we're going to talk about the abstracted parent. And this is where we're using heavy OOP principles in order to heighten the capabilities of our automation framework. So first off, like I said, is the isolated framework. And what I mean by isolated framework is that the setup is primarily just two frameworks that just happen to be coexisting side by side. So to that end, we have a situation where we have an Android test case and an iOS test case. A lot of times the number of tests in Android and iOS will be the same, but sometimes they won't. The nice part about an isolated framework is that we have full flexibility to have an iOS only test or an Android only test. You can even package them up and distribute them differently, but that's the main thing, is that these are technically just two different frameworks. They're not really sharing any complexity or capability, but you're writing stuff twice. And a lot of times it's just reworking the exact same thing and changing some selectors, but it is definitely more assets to manage and more things to look through and duplicate whenever you're working on stuff. A lot of times the strategy here would be one sprint working on an iOS feature set or test set, and then an Android test set, or else having extra people to be able to be paired. One is doing Android, one is doing iOS. So from that, we talk about kind of the cross-platform approach for the isolated framework. Due to the fact that the framework is essentially two frameworks side by side, it is an Android framework and an iOS framework, there's not really any complexity to this scenario. The Android tests will run on Android and the iOS test will run on Android. They both have their individualized configurations, and therefore they can run, but you have to manage some of the configuration stuff in the testing groups differently because you have to treat them like two individual frameworks. And then like application divergence, once again, it's the same. It's two frameworks living side by side with each other. So you don't really have to worry about app divergence because you're making the page object models for every single scene over and over again, whether it's an iOS group or an Android group. So this just sets itself up where you don't have to worry about accounting for app divergence. It just happens, which is nice, but you have the overproduction of code again. And then let's talk about the performance situation of this. Isolated framework is kind of is the simplest best case scenario. And we have a little bit of an animation here. We do one click element call, and then out of that, we get a find element call. And then we get our element back, and then we click. So we are pulling one element into place, or trying to find one element. We are clicking that single element. We're reusing the piece over and over again. So there's not really any wasted steps. It's kind of a one-for-one scenario here. Each interaction has one element pulled, which is a really efficient, simplistic scenario. And then the last piece that is worth talking about here is kind of the shared code approach. Due to the fact that they're isolated frameworks, we're going to be using static code libraries and stuff like that to keep some of those interactions the same. And if you can abstract it and make it generic enough, you can have that code usable on both sides. But sometimes, depending on the elements and the drivers that you're using, you don't have that ability. So the flexibility of the shared code stack is small. While usable, it doesn't exactly offer the power and flexibility that we want. So the benefits of the isolated framework overall is out of the box specific tests. You don't have to necessarily worry about shutting down a specific test that is iOS or Android only. It just inherently works that way because you're duplicating your test classes, which is a nice piece, but it comes at a decent amount of cost and consequence. The abstraction is not required for the UX divergence. So when the app divergence happens, you don't have to use intermediate or advanced techniques to account for the divergence. So once again, it's very simplistic. And then also enforce single responsibility on the test and page object level. That can happen each test, each page object model is specifically referencing their platform, their device type, and it is a situation that it has to be manually enforced. There isn't really anything from the programming stack that is enforcing it aside from outside tools. So that's kind of the big pieces that we get that single responsibility enforcement, but it's because of the duplication, because you're technically duplicating your work. And then your consequences are your test coverage desynchronization, whether or not that specific test is already covered on the Android side or the iOS side when it's already living in the opposing side. So that's one thing that you kind of get, and especially with ALM tools now, it creates a unique reporting scenario in terms of the testing endpoint. So usually a testing endpoint talks about platform, the version, the app version, stuff like that. And in this scenario, that reporting piece isn't as fluid. You have to make sure that your reporting framework is on top of its game in order to make sure that you report results to the right location. And then the last part, the code sharing is painful because of the fact that we're duplicating work and it's very specific on each side. Therefore, like you're using a lot of static methods for data manipulation or element manipulation, but you also have a lot of duplicated code as well. So the isolated framework is simple to use and simple to put together, but it doesn't exactly give you the flexibility, and you're recreating a healthy amount of work. So the next so if we walk through our checklist, we don't get our single test class, and that's unfortunate. That's one of the nice pieces and the nice guidelines that we have. The cross-platform stuff, it's kind of there because of the fact that you're building two individual frameworks. It's not cross-platform because of the ingenuity that you put into place on building the framework. It's because of the fact that you duplicated your framework source. So I kind of give it I give it a maybe, the old college try, but I don't give it a lot of credit. App Divergence, it handles it because of the fact that it's double platform or double framework. The performance is there, but the shared code is not as good as what we would want it to be in order for it to be acceptable. So we'll move on to the conditional page model approach. So this isn't much different from what we are used to doing in the isolated framework. The difference here is that we're leveraging a lot of conditions. So we're able to get our single test class. And we don't have to really get fancy with our names or in terms of denoting whether it's an iOS page model or an Android page model. We can kind of just go around, through the process like we normally would do on automating a web page, which is nice. There's not a lot of complexity, but where the complexity kind of comes into place is once you get to the page object model and create that cross-platform work. So in the conditional page model, we take a look at the driver and what type of driver it is, case in point by the code snippet here, whether it's an iOS driver or an Android driver, and then we return the selector based off of that, based off of the type of driver it is. So the paired object model is very well aware of what type of platform driver we're using, therefore allowing us to decide what selector we're using. But that means that we now have these conditionals that are consistently going to cause an issue, and even if the dependency is updated, maybe some of that stuff is broken. So there, all of a sudden, you have a whole bunch of maintenance code that you have to update in order for your automation to get back to working. For application divergence, this is along the same lines that we were talking about with the selector. So with the selector, we're doing the conditional on the Android and iOS driver. With the app divergence piece, is more or less the same thing. We can have our generic login method, but we also then have the Android and iOS methods. So from those components, we're able to break it down and start to encapsulate some of the logic, but we still have a situation where we're increasing complexity, and in this scenario, the page object models can get massive, and not the organization can kind of can start to get rough, and that is one of the hard parts for ramping up a new resource on a project, is this hyper complexity and a lot of branching scenarios for this automation code. And then on a performance level, we have once again our primary click element approach, and then the configuration, which will dictate the direction that the automation goes, whether it's an Android driver or an iOS driver, then all of a sudden makes the decision, and then we get the same level of efficiency as the isolated framework. After that initial conditional happens, then it's everything the exact same way that the isolated framework was doing, where we're grabbing one element and using that one element rather than creating a library of elements along the way. So this is a valuable piece for the performance part. And then for the shared code piece, we're still doing page object models for the Android and iOS piece, but they're all merged together in the exact same page object model, which is that larger box. Also in there, we're able to put in some of the shared code, so the shared code is a little bit closer to where the page object model logic is, which allows for that sharing to be a little bit more flexible and agnostic in its decisions. So that it definitely helps in the shared code perspective, but it doesn't necessarily make everything as efficient and flexible as we want it to be. For our benefits, we're going to talk about like the test reporting becomes more of a run configuration detail. So this kind of takes the entire piece of the isolated framework, where there are technically two frameworks running aside, and then it all of a sudden pulls it together and starts, at least on the test level, the run configuration being the dictating component there. So therefore, at the test level, the test runner decides that's Android, and then it continues on from there and goes through all the conditionals. The page object models are allowed to do more code sharing, which is a really nice piece for not duplication. We're starting to slim down that duplication. The page object models rely heavily on the driver, understanding what driver it is and what type it is. If it can't figure out what type it is, whether it be a dependency update or switching out a dependency for a different library, all of a sudden you're in this situation where you have to do a lot of maintenance and upkeep. And then the test coverage stays consistent across all platforms. So this is a situation where we have one test class, so we know that if it's in Android, it's most likely in iOS, unless we've told it to be an Android or iOS only test. And then the consequences of the conditional page model is extra work for platform specific tests. You have there will be times where the work piece is not in iOS in the page object model. So therefore, you're going to have to elegantly handle those scenarios. With page object models, to stop respecting single responsibility. The page object models will have platform-specific drivers called out, platform-specific methods, and selectors as well. So it's a situation where each page model will have all the associated platform references in there. Not exactly a good organized piece, and once again, page object models can get really large because of this merging of the two platforms. The conditional statement is used at every instance of app divergence, as well as potentially device divergence. And as you can see in the sub-bullet, a high probability that that every selector will have to go through the exact same conditional process. So it's not exactly the perfect scenario, because app divergence and device divergence get us a little bit complicated. So when we break down the conditional page model, we get our single test class, which is a good movement in the right direction. The cross-platform approach, due to the fact that we now have a run configuration that can dictate the conditional process inside the page object models, we get our cross-platform approach, which is fantastic. We have our first two guiding principles satisfied. The app divergence piece, we're giving it a maybe. It's not exactly efficient. And the reason why this gets bad is because we have to conditional on every single scenario that could be divergent. Case in point, selectors, by nature of having a different platform, iOS versus Android in this example, the selectors will be different. They don't have a common selector group. So we're going to give them kind of a maybe on their app divergence approach. The performance is still the same as isolated framework because of the fact that we're not wasting any moves. We are grabbing the elements we need, and that's it, which is a good piece, especially when we get farther into the DevOps pipeline for mobile automation and mobile testing. That it's a key value that you'll see in the next section. The shared code piece, they're closer to the page object models, which is really nice. We're allowed to create some agnosticism inside of the methods, but it's not as clean as we want it to be. It definitely has some room to grow. So we're going to get to the next big section, and this one, it has a unique place in kind of the automation industry, the sphere, the programming sphere. The Page Factory makes a lot of things simple, but it has a decent amount of consequence to enabling that capability. And I'll go into depth about that as we walk through this. So with the Page Factory, we get our single test class, which is fantastic. It looks similar to the exact same way the to the conditional page object model, because all the work is being handled inside the page object model in terms of differentiating between the two operating systems. So we get that one for free, which is a nice part, because the next piece is a little bit different. So the page factory, it gives us that cross-platform approach. And in the top section here, you can see the Android and iOS annotations. You can see that I'm calling out an ID for Android, which is pretty standard, and then I'm calling out the name field for iOS. And then it is all being deposited inside of an Appium element that is right below it. All this happens via reflection, and the unique piece that is Page Factory creates this win and this negative space or this consequence at the same time, because of the fact that reflection can't happen on demand. It has to be pre-processed. So, and especially the annotation piece. So that's kind of where we're going to get into some muddy water. So in terms of instantiating objects, the way that that flow typically goes with Page Factory is that we set up the username field, which is a standard interaction. We're doing the password, and then when we want to move on to the next page, we have to do this Page Factory init elements and using the field decorator. So we have to start populating the elements before we're allowed to start interacting with the page. And it is entirely possible that some people could be getting ahead of me on this one, but you're probably right, but we're getting there. But another thing that you can see right underneath the try is that we're doing an explicit thread sleep. We're explicitly waiting for 10 seconds to go by, and that's not a good practice when it comes to building out an automation framework and doing coding practices, the standard coding conventions. So let's get into app divergence. So the app divergence here is the same as the conditional, because of the fact that we're holding the iOS and Android elements in the exact same class. We don't have nearly as many conditionals. Luckily here, the conditionals are solely dependent on the methods, app divergent methods and scenarios like that. But some of the, due to the fact that we're using like an Appium element, we have at least a more generic element. So we have the ability to at least do some common code sharing there. And now we're going to talk about the performance, and kind of this is the big part of page factoring and why I don't feel that is the best approach for utilizing for utilizing inside of automations, definitely in mobile automation, but the things that happen in Page Factory also happen in web automation as well using Selenium. So in this situation, we send out the click element call, but then after that, we have all the selectors that need to be populated inside that page object model before we're allowed to do anything. So we make our Page Factory init elements call, but now we have to go through the process of grabbing every single element that we call out, and every single one of them has to be taken care of. So if one of those elements are dynamic, or if they're stale, you get into this really unique, really unfortunate scenario where either the page model doesn't fully instantiate, or you will have stale elements when you finally get to it. So now that we've done all of that, we can now use the single interaction reuse. So we're having about a 25% hit rate. We're doing 3 times or 3 pieces of extra work for the sake of just clicking on one element. And that, while happening local, say with a web page, with Selenium directly to a web page, that's a one-to-one interaction and it's very simple. But if we get bigger in our needs and capabilities, whether it be testing infrastructure, whatever the case may be, or specifically in Appium, you have a lot of little servers that are interacting with each other. So here on a local level, we have the framework talking to the Appium server. If you're running an Android test, it talks directly to the Android subsystems to allow the automation to happen. For iOS, as of iOS 10, so 5 years ago, you now need a WebDriver agent app installed in order to make those automation calls happen. So you have two HTTP servers in place, and they're both made out of Node, if I remember correctly. But you have two of those in place, and those the talk time between those have lag. So even in a local scenario, it's not that bad. But once we get to cloud, that it gets worse because of the fact that we have to travel over the internet now. We now have to deal with the grid server, which if it's a testing infrastructure or if it's a heavy use time, then all of a sudden we have lag there. We then have the Appium server or to the device or the WebDriver agent as well. So you can see how that talk time is going to start making your automation grow. And if you're all of a sudden doing your interactions where you have to pull all of your selectors and instantiate all your elements beforehand, all of a sudden you could be waiting, 30, 40, 60 seconds for that one interaction to happen. So it's not exactly a quick and efficient process. You're pulling about 3 to 4 times as much data as you would probably need in our example. So that's the big piece about page factory, and this works on both the Selenium side and the Appium side because Appium is just a remote WebDriver of Selenium. So they both kind of hit this exact same spot, whereas if we use intelligent weighting and on-demand selector work and using lazy instantiation, we can get a better performance framework out of it while getting the flexibility. And then here's the shared code scenario. We have our center super page object model in the middle. We have some shared code steps, some shared selectors and identifiers, which is really nice at getting our selectors in the same on the same line and just using annotations to do it. That gives us a little bit of breathing room and flexibility there. And then the platform-specific app divergent scenarios for iOS and Android are on the right-hand side of that box. So we're starting to get closer and closer to our dream goal, our idealized approach. It just comes at a cost on the performance scale. And a lot of times with cloud testing infrastructures, what I have consistently quoted to clients is that it is usually a 1.5 to 2.5 times execution duration because of the fact that of all that talk time. So, and that's on an efficient framework. So if you take the page factory and extrapolate that out, you could be testing for 8 hours and not even being done yet. So just a little bit of food for thought in terms of page factory. I know that it makes stuff simple, but it also creates a decent amount of performance lag. So the benefits for page factory is test reporting stays a configuration detail. We saw that on the test level. Common test and all the work is kind of all the differentiation work is handled in the page object model, whether it happens if you have reflection or conditional. Page object models rely on web elements more than the driver. So we're starting to pull ourselves away from relying on that driver and becoming more agnostic. We're able to interact with stuff more consistently. And technically, if we had a page object model and we want to pull it out and drop it into a new spot, we wouldn't have to worry so much about the driver complications. Is more of the individual elements. Once again, you get to use more and more shared code because of the fact that the elements are getting agnostic and becoming more agnostic, and then our test coverage stays consistent across all the platforms that we're going to test. But the consequences of this scenario kind of come to light. The extra work needed for platform-specific tests is the same that it was in the conditional page object model, which is nice. Is actually reduced a little bit because of the fact that we only have to put the specific number of annotations above an element based off of whether it's Android or iOS. The conditional statements are needed for every instance of app divergence, but it's only inside the methods or the functional workflow logic. So that's at least simplifying some of our scenario from the previous one. Dynamic UI changes cause high maintenance and inflated execution times, both in test fragility and also explicit waiting and the stale element piece. So that becomes kind of a big thing that you have to mitigate. And usually the way to mitigate it is by taking your time table and extending it significantly. Execution time becomes bloated because of how the page factory operates. We've covered that. Page factory uses a complex method called, so part of this is also personal preference, but I don't really enjoy having a magic method in terms of my frameworks. And what I mean by magic method is a situation where the method is hyper complex and makes life easier, but that hyper complexity could eventually break and I don't have the ability to mitigate it or fix it. And in Page Factory is such a core component to these page object models, where if I was to mitigate it, my mitigation route is removing Page Factory from the page object models altogether. That's my choice. So that's not exactly the best scenario. I can't work around it. I just have to remove it or tolerate the failures until the fix happens. And then device divergence becomes difficult. That's where you all of a sudden start having to do doing the isolated framework, like having a tablet framework and having a phone framework and so on and so on. So there's some consequence there. We get the selector ease on the platform level, but we don't necessarily get the layout and form factor flexibility. So let's cover it real quick. So Page Factory, we get the single test. Cross-platform, we also get that. The app divergence is kind of a maybe. We don't have to worry about the selectors as much, but we still have to worry about the functional flows. The performance is not there at all. This is the first one that we've had a decisive no on because of the amount of extra work that the framework and the Page Factory have to do in order to function normally. So this is kind of the big difference in Page Factory, is that it's just not performant. And then shared code, we have some sharing of code. We still need app divergent scenarios, but we're getting closer and closer to that shared code scenario where code that benefits one platform can benefit the other platform as well. And then we get to the last piece of this journey, which is the abstracted parent approach. This relies heavily on object-oriented principles and using the knowledge that we've kind of learned over the course of programming. So this is kind of an important piece, and for me, it actually made me a better developer overall, both developer and quality engineer, because of the fact that I've solidified these principles and practices. I am now able to teach people more effectively, and I'm able to build better frameworks for it. So there's some appreciation and love for the abstracted parent approach. So we get our abstract parent test class, which the primary test classes will consistently be the same as we've had it before, where everything makes sense in terms of the readability of the test. You can kind of see where what we're getting at. It almost kind of has a simplicity, a real world language simplicity. Like on the login page, we're going to click the login button. So we're maintaining that still. The major difference in the abstract parent is that we need something to decide the track that we're going to start running on. And the way we do that is that in a base class, we have the abstract parent page object model held inside the base class. We create a before method approach, and then based off of the driver, which is only on the test level, where we really care about what type of driver it is, we then instantiate the proper page model and file that away in the login page, so that way the page on the next level, the child of the base test, is now able to utilize that initial page to start off. But one of the nice parts that kind of comes out of this is because of the fact that we're holding the platform divergence on the test level, it means that everything below that is kind of on its own track and allows us to enforce that without actually putting effort, like any extra effort forth. So for the cross-platform piece, we have our single test class that we see on the left-hand side. The dotted box with the A is our abstract parent. That sets the initial contract for the page object model and how we're going and what methods we have access to and how we can work with them. And then next, based off of what abstract parent has, with the conditional inside the test class and per the abstract parent, we're now able to move ourselves into the platform specific code. So we have the single responsibility in the page object models. We're able to do that both on the selector level and the method level, but also the references. All the references that will be inside those page object models will be either iOS or Android. If you see one of those references not being of the appropriate platform, you know that you potentially are referencing the wrong model. So it kind of gives you extra context clues and indicators for this situation. And then here's kind of an example of how the cross-platform piece looks across all three pages. So we have the abstract login page, which we're kind of defining that initial contract, but then on the Android and iOS page, due to the fact that we're extending the login page, the abstract login page, we already know what methods that we have to comply with. It is worthwhile noting that as languages have progressed, it has gotten to the point where using an interface, implementing an interface, is also a viable option rather than extending an abstract parent. At the point of time of working through this thought process, interfaces didn't have that flexibility. And initially I was doing that work inside of Java and earlier Java's versions. So that's kind of an important detail, is that right in these scenarios, I'm using an abstract parent, but technically an interface could work along the same lines. It just depends what your needs are and how mature the language is as well. So with app divergence, the abstraction kind of just becomes the same, where we're waiting for views to load, the set username, the set passwords, the clicking on login. So therefore, we're able to have generic methods that are kind of BDD or behavior-driven development, like Gherkin. It entertains some of those pieces. And we also see up here the app divergence component, where say the username, password, and login and logged in view are all on a different view. This allows us to handle that appropriately versus like the iOS scenario where username and password are on the exact same view and the login button is in the top right corner. We're only waiting for the loading to happen once, but the method call that is going to happen will always be to .login. And then we're going to show off the performance real quick. So an Android configuration comes in, and it immediately switches to the abstracts of the Android side. We get the Android route, and that works as we expect. So we're getting that efficiency of work. We're not having multiple calls. It's one element in, one element out. And iOS kind of goes through the exact same approach as well. They switch up the branch and they keep moving. And the shared code approach, we can keep all of our shared code in the abstract level, which is an important detail. We're able to fully make the page object models agnostic and platform specific. The abstract is the agnostic level. The platform specific is the iOS and Android page models. And so that's what we're kind of proving out here, is that we can now start using shared code the way that we want to. And the benefits of it, we still have the configuration detail piece that we've had ever since the conditional. The page object model throw becomes that app blueprint. So we have the abstract parent for the shared code, and the specific code in the child classes, we get that single responsibility. The test coverage stays synced across all platforms, and we respect our single responsibility. The abstraction allows for app and device divergence, both on whether it be iOS, Android, phone, tablet. Maintenance is reduced because our errors will lead us to the specific platform or the common workflows in the abstract. And the abstract methods also help enforce that consistency. The consequences, extra work is needed for some of the platform specific tests. We kind of saw that in every single iteration of this step of this journey. So that's nothing really new at this point. Larger framework asset count. So you're making significantly more page object models, but when it comes down to it, the files are small. We're not exactly working with the old hard drive size of 4 gigs. Is the most you're getting in a hard drive, so we're lucky there. And depending on the language you use, sharing code in the parent can create a small anti-pattern. A lot of times when I see that problem, it's specifically scripting and compiled languages. So with the abstract parent, we cover all of our guiding principles with a yes, and we are able to step out and get some extra of those stretch goals, like the readability, which is kind of Gherkin-like, and some of those other parts. So that's kind of where my journey has led me in terms of mobile automation, and I've actually employed some of this in web automation as well, is using some of these skills. And thank you.